So finally, just to finish off the geometric sequences, when you're doing recursive or explicit forms, you basically need the two same things. You need the first term and you need the common ratio. So looking at this table, you actually already have your first term. Look, when my n is always the term number. And so when my term is 1, when my actual number is 5. So my first term is 5. And look, from 5 to 10 to 20 to 40. What are we multiplying? Remember, it's a geometric sequence. What are we multiplying to get it from 5 to 10, 10 to 20, 20, 40? You guessed it, it's already there. It's times 2. So that is our common ratio. So now with this information, let's turn this table, this sequence, into a recursive and explicit. So quick review. If you want to do recursive, we always write the first term. Let's pick any letter you want. Let's call it a b of 1. So my b of 1, the 1 inside is always the term number. So that will be equal to 5. And b of n equals 2. This is always the same, guys. b of n minus 1. And on the outside, we multiply it by the common ratio, which would be times 2. So that's basically it for recursive. Pretty simple. Where it gets fun is in explicit form, because you're going to find out right now. So again, let's use the same letter, b, and let me write this in a thinner pencil. B of 1 equals. Now the explicit doesn't have two rows for the formula. We just go straight at it. My first term was 5, so it's going to be a 5 times. In the parentheses, we put the common ratio, which was a 2, and that will be to the power of n minus 1. And that's basically the explicit in its first form. If you guys haven't seen the other videos, there are two ways you could write this. And I'll actually look upward in the notes, because or the previous video on the channel, because we actually need some review on exponents if you want to find the second form. Let me show you why. Well, that's a 5 times 2 to the n minus 1. But couldn't we do this, 2 to the n minus 1? Couldn't it be written this way? 2n times 2 to the power of negative 1. Isn't that a possibility? And I could keep it in parentheses, but it's just a 2. It's by itself. So basically, that's another way you could write it, because I'm separating the exponents. Now, before I start moving forward, we never like exponents to be negative, so I can actually switch this one to a positive exponent. And do you guys remember how to do that? Again, that's a over 1, and if it's a negative, I gotta move it to the other side. So if it was down here negative, I move it up. It all depends where it is originally. So let's move it down, guys, and we're actually gonna have 1 over 2 to the power of positive 1. Well, guys, 2 to the 1 is simply a 2, isn't it? So we don't have to write that one anymore. And what can we combine? We cannot combine anything with this one because it doesn't have, nothing else has an n. And so basically we can multiply 5 times 1/2. And when you multiply fractions, you got to turn both of them into fractions. So 5 over 1 times 1 over 2 is basically 5 over 2 times 2 to the power of n. And that is basically the second version of the same explicit formula. You got to know both in case they show you one and not the other. And that's basically the review for geometric sequences.